This slide concludes these chapters on the design of the connections of the steel structures. Basically, we have covered three types of connections. The first one is the tensile splice of steel plates. The second one is the bolted end plate connections as a beam to column connections. And the third one is the bolted wet clip connections, which is also the beam to column connections of the steel structures. In general, these are the scopes to be checked for the connections. For you to determine which to be checked, first you have to look into the design configurations of the connections. Let us first look into the tensile splice. Due to the existence of the bolt hole, you will need to check for the edge distance and the spacing for the tensile splice. Same goes to the other connections involving bolt holes. Next, if it is a beam to column connections, the ductility cannot be secured directly based on the ductility of the connections itself. Therefore, you will need to check for the ductility for the beam to column connections. In fact, you can choose to use the same set of formula to check for the ductility for the tensile splice, but the ductility will always pass here because the tensile force is direct to the directions of the members, and the ductility of the member itself can secure the ductility of the connections. In another word, if you are dealing with beam to column connections, you will have to check for the ductility. Next is the tensile resistance of the plate. Among these three types of the connections, only the tensile splice are having the axial loops into the member. Therefore, you will have to check for the axial loops for the tensile splice only. As for the beam to column connections, there won't be any axial loops. Instead, there will be moment and flexural loops acting on the connections. They do not involve with the direct tensions of the connections. Next, you have to check for the shear resistance of the bolt. With the existence of the bolt, you will have to check for the shear resistance of the bolt. As all three connections involve bolted connections, that means all three will have to check for the bolt resistance in shear. Again, when you have bolts, there will be bolt hole, and when you have bolt hole, under load, there will be bearing resistance of the bolt hole. Therefore, all three of the connections will have to check for the bearing resistance of the bolt hole.